Hello everybody and welcome back to my channel. This is Yamaya's Learning Sessions. If you hear any background noise, there are people talking in the back, but we're trying to make it work, you know? Okay, so this is Quest Homework 10. This is problem number 11. I decided just to work out the more complex problems, just because some of them are like one equation, but some of them are like you need 2 or 3 equations to find your last equation. So here we go. The problem says a sound wave has a frequency of 645 hertz in air and a wavelength of 0.54 meters. What is the temperature of the air? Relate the speed of sound into temperature in units of Kelvin, but answer in units of Celsius. Assume the velocity of sound at 0 degrees Celsius is 332 meters per second. It wants the answer in degrees Celsius, okay? So it tells us that we're going to get our answer in units of Kelvin, but we need to convert it. Our final answer needs to be in Celsius, right? So this is the equation we're going to be using. So the equation for sound and air is velocity equals, final velocity equals initial velocity times the square root of the temperature over 273.15. So this is what we're going to be using. Sorry, this is, hold on, I'm just going to rewrite it because the line is bothering me. Okay. That's semi-better. Okay, it's okay. Okay, so it's asking for the temperature, so obviously this is what we're looking for. This is our unknown variable, okay? So we have it gives us the frequency, it gives us the wavelength, and it also gives us the initial velocity. Okay, but then, so we have initial velocity right here. We're looking for t, we have decimal point, sorry about that. And we have but if you're wondering, well, Yamaya, the problem doesn't give us the final velocity. Well, what do you mean? How are we going to solve for it, you know? And that's a good thing, because we're going to solve for this and then solve for this, okay? Because we need to find the final velocity in order to find the temperature. So there only could be one variable to solve for, okay? So we're going to use this equation to find velocity. Velocity equals frequency times wavelength. Now maybe it's coming to you because initially you could think, this is what my thought process was in the beginning. Well, why is it giving us frequency and wavelength if there's no frequency and wavelength in the equation we're trying to solve for temperature? But we need frequency and wavelength to solve for the final velocity. That way we can solve for temperature. So they all work together to help us find the final answer. Okay, so final velocity is equal to frequency times wavelength. So that means 645 times 0.54. And that should give us velocities equal to 348.3. Okay, so now we can plug in all our numbers into our equation. So 348.3 equals to 332 times the square root of temperature over 273.15. First thing we're going to do, we're trying to isolate the variable. So we need to get rid of a constant. In this case, it's 332. So divide both sides by 332. And that should give us 1.0490. Bring the square root down. I'm sorry. If I don't press hard enough, then the decimal point won't show up. Okay. Okay, so in order to get rid of the square root, we need to square it. It's the opposite. So just square that. And then it just gets rid of the square root. So, but you have to square this number right here, okay? So when you square that, you can put this into your calculator if you want, but basically what we're going to get is 1.0490 squared equal to the square root of t over 273.5, right? So it just gets rid, sorry about that. It just gets rid of the square root. So it's just like a regular fraction, basically. So when we square it, it's going to get rid of the square root, right? Now we can cross multiply. Sorry, it always looks super ugly. Okay, we're going to cross multiply. I'm not going to do the little butterfly thing because it looks ugly. So basically what we're going to do is we're going to multiply 1.0490 squared times 273.15, and then t just gets brought down because t times 1 is t, and that should give us t equals 300.5745. Okay, but that is in Kelvin, so it gives us the temperature in Kelvin, but when we refer back to the equation, it says it wants the answer in units of Celsius or degrees of Celsius, right? Okay, so now we have to get the answer in Celsius, right? So we're going to use this equation. Celsius equals Kelvin minus 273.15. So basically we're just going to take 300.5745 minus 273.15, and that's going to give us an answer of 27.4748. And this, my friends, is our final answer. Okay, so just going to recap what we did a little bit. Made a t-chart. Always start off your problems with the t-chart. If it gives you a certain, like, different values and things like that, make a t-chart. It'll just keep you organized and you can know, okay, I have this, and I have this. Then we identified the equation we needed to use to find temperature. We figured out that we needed to find the final velocity in order to solve for the temperature, so we used that using velocity equals to frequency times wavelength. We plugged all our knowns into the equation, and we solved for t in Kelvin, but then we said, okay, well, we need this value in Celsius in order to get it right in Quest. We used that by taking the Kelvin and subtracting 273.15, and that gave us an answer of 27.4748 Celsius, okay? So I hope that this video helped you in some way. Please know that these are my numbers for my problems, so if you could have the same numbers and you can also have different, just make sure that you're using your numbers, and always go at 4 decimal places in Quest. And I hope that this helped you. So, yes, just if you have any questions, comments, or concerns, please leave them in the comments below. I would love your feedback, and I hope you have a beautiful and blessed day. Bye-bye.